Hello, my name is Bezad Agdashi and I'm a research associate at Institute for Transportation Research and Education at North Carolina State University. In this video, I'm going to talk about active traffic and demand management analysis in STREETVAL. STREETVAL has been developed in Java environment. As such, it can be run on any operating system including Windows and Mac OS. In order to execute STREETVAL, we need to download and install Java runtime environment, which can be accessible via the link is provided on this slide. Just as a note, Java runtime environment version 8 and later needs to be installed in order for true execution of STREETVAL. After installing Java runtime environment and after downloading STREETVAL, we can go to the file that we have downloaded, which has a .jar extension, and by double clicking on that, the main window of the STREETVAL can be seen. For this demo, I'm going to start with the example from scratch. For this purpose, I'm going to the project menu and select new project from that menu. By selecting that, a window will be opened which will show the global parameters needed for this analysis. For the examples that we have on this demo, I'm going to leave all the parameters to their default value, except that I'm going to reduce number of segments in the arterial to 4 segments, which will leave me with 5 intersections and 4 links. By clicking on the next button, our facility will be generated. As you can see, we have the graphic representation of the facility at the center of the screen, as well as the detailed input-output table that user can use to specify detailed parameters for each intersection and link by clicking on that thing in the graph. STREETVAL comes with a default data set when we create any facility, which means that all the parameters and values are pre-filled. As you can see in this example, we do have a volume close to equal to 1000 vehicles per hour on both approaches and both directions. So since in this example I'm going to test reversible center lanes as my ATDM strategy, I want to increase the volume in one direction to see the benefit of these reversible center lanes. For this purpose, I will click on the field data button and go to the intersection, and for all intersection through movement eastbound direction, I want to increase the volume to 1500. So as you can see here right now, by clicking on any intersections, our eastbound through volume is 1500. Since ATDM analysis in the context of HCM is built on top of the reliability analysis, I need to first pursue with reliability analysis before doing any ATDM strategy implementation. For this purpose, I'm going to go to the reliability analysis frame and click on the generate scenarios, which will generate for us the reliability scenarios. By clicking on this screen, on this button, this screen will show up where we need to configure our reliability analysis. As you can see, this window has 4 tabs where we can configure our reliability analysis. On the first tab, which is called setup, we can define the reliability reporting period, which by default is from 1st of January to the 7th of January for a week, and our study period is from 4:30 p.m. to 6:30 p.m., which I'm going to leave it as is, and our traffic count date is January 23rd today, and traffic hour is 5 p.m. I'm going to leave all these values to their default value. I'm going to go to the weather tab and select the city from this list. I'm going with Raleigh, North Carolina, and by selecting this city and extracting the probability for different weather conditions specified in terms of precipitation and temperature, I can populate this table so that the reliability scenario reflects these weather data. By going to the demand tab, we can configure the demand variation across the weekdays and also as well as the months of the year. As you can see, there are parameters here by default, HCM suggestions, which I'm going to leave them as is. At the bottom of this tab, we do have a section for hourly demand multipliers, where we can define the demand fluctuation within the hours of the day. As you know, at the very first that we created our facility, each facility based on HCM's definition is a 15-minute analysis, but in the reliability we specified that we want to consider longer study period from 4:30 p.m. to 6:30. So this is where we can come and basically input the demand variation for different hours of the day. Alternatively, we do have access to this radio button, where we can go here and define exact volumes that we see for all intersections that we have from 4:30 to 6:30 p.m. So for this example, I'm going to stick with hourly default factors, but I need to note that if a user has access to the volume data for each 15 minutes or different data sets of the operation of the facility, they can come here and modify these values. So with that said, let me bring back to 1500. I'm going to the hourly factors, which will take the demand values, our volumes for all intersection, all movements, and modify it based on this default hourly profile. So with that said, I'm going to the incidence tab. Over here we can define the likelihood for having incidents on each segment and also each intersection, along with their detailed characteristics, which I'm going to leave it to the default values that STREETVAL has. By clicking generate and run scenarios, our reliability scenarios will be created, and we can come to the left side pane and click on this branch to see all the reliability scenarios that are created based on the parameters that we have specified. Now that we are done with the reliability analysis, we can take a look at the reliability performance measures of this facility by clicking on the output summary button, which will open this window for us. As you can see here, we are able to see the PDF and CDF of travel time index for this facility on the eastbound direction, as well as key reliability performance measures that are listed in the table at the bottom of this window. As you can see right now, for example, the mean TTI for eastbound direction is 2.92, whereas for the westbound direction is 2.5, and this better operation in the westbound direction is due to a lower volume that we have for the through traffic on this direction. So with that said, I'm going to click on the close button, and I want to pursue with our ATDM analysis. In order to implement ATDM strategies, which in this case I'm going to use reversible center lanes, I have to click on the generate button here in the ATDM analysis, so that this window will be opened, and this is the main window that is used to implement our ATDM strategies. So as you can see on this window, we have 4 major tabs, which are adjustment for a number of lanes. We have the adjusted offsets, we have adjusted phase splits, and also adjusted cycle length. These are parameters that we can change in order to implement our ATDM analysis. So for adjusted number of lanes, as you can see, if we come down to the tab, we have 5 more tabs, which is for each intersection, and we can have put the numbers that we want to adjust. For example, since our eastbound directions volume is higher than westbound, I want to assign 1 more lane to the eastbound direction from 4:30 to 6:30 p.m. in order to make the balance between number of lanes that we have before and after ATDM strategy implementation. I need to deduct 1 lane from the westbound, and this way I have modeled the reversible center lanes that will operate for eastbound direction as an ATDM strategy. So I have gone through other intersections, and as you can see, I have added one lane to the eastbound direction, and I have deducted one lane from westbound direction. So this is how I have modeled the reversible center lanes. Of course, there's one point that I need to note, and that is that STREETVAL and HTDM does not do the signal timing optimization. If due to this number of lane change, we need to change other parameters related to signal timing, user need to come here and change those numbers as well. For this example, I'm not going to change those and generate my ATDM scenarios and pursue with the ATDM analysis. So after pursuing with ATDM analysis, you can see that we have another branch here which will contain the scenarios for after implementing ATDM strategies. By clicking on the output summary button, this window will be open, where it will reveal the reliability level impact of the implemented strategies. So as you can see here in this window, by adding a lane to the eastbound direction, our after performance measures, which is shown in this graph, shows a better performance in terms of TTI travel time index in this direction. We can go and take a look at westbound direction, which shows that our after implementing ATDM strategy, TTI cumulative distribution curve shows a poor operation in the westbound direction, as we were expecting on this green graph. One of the things that the STREETVAL has is that it can give you the overall performance of the arterial and the corridor that has two directions. So for the combined direction, we see that after implementing ATDM strategy for certain TTI ranges, we see a better performance, whereas in some other TTI ranges, the before implementation, we had seen a better performance. But overall, as you can see here, after implementing ATDM strategy, our mean TTI is equal to 2.73, whereas before that it was 2.79 for both directions, which shows a slight improvement on both directions. So in this example and demo, I show how to model reversible center lanes. There are a few other notes that I want to mention in the configuration of ATDM strategies. Primarily, STREETVAL-ATDM can analyze reversible center lanes as well as dynamic lane groupings on the intersections. One thing that I need to note is that for the number of lanes, we use the adjustments for the original number of lanes that we had on the facility, whereas for the offsets and phase splits and cycle lengths, user need to provide the adjusted values. So these are not adjustments to the values that we have in the original model. For example, if we want to change the cycle length, we have to provide the adjusted cycle length directly here, and these values will be used directly by a STREETVAL at the time that we want to generate ATDM scenarios. One more feature of the STREETVAL that I want to highlight before finishing this presentation is the open and save capability of the STREETVAL. For this purpose, user can always go and hit on the project menu save button to save the project, and they can always open the project here. So for example, I've already saved this project. I'm going to open it. I have saved it in my desktop under the name demo example 1. Once we click on that, we can have our analysis being opened here. And one of the things that STREETVAL does is that it only saves the inputs, so user can again pursue with the reliability analysis, which should take just few seconds, and then pursue with ATDM as well. And as you can see here in the ATDM menu, all the values are already saved. If you have any questions or if you find any bugs, you can always contact me by the email address that is provided in this slide. Thank you very much.